Okay, we are moving on to 4.4, which is about isosceles triangles. So it's the isosceles triangles theorems. We are going to try to apply theorems and corollaries about isosceles triangles. And hopefully when you see some of these corollaries, they're going to look familiar to you. So first thing, if you don't have a compass and straight edge, you want to pause now and go back and get one. So you need a compass and a straight edge. We're going to do some quick constructions just to try to get our point across and our understanding. Okay, if you do have your compass and straight edge now, the first thing you need to do is construct an isosceles triangle. Well, many of you already did this on the test. So the first thing you want to start with is a base, right? So you can start with any sized base. You can then open your compass to any height or width you want to, and then you're going to do your little swoops. Make your arc here. I'm going to go to the other side. The other end point, I'm going to make my arc here to see where they intersect. Then I'm going to get my straight edge and I'm going to connect it from that point of intersection out to the end points of the base. So here is my isosceles triangle. So that's a little review of what you've done on the test recently. So when you draw your isosceles triangle, you should mark this. So now we know that these two sides are the congruent sides, therefore making it an isosceles triangle. Well, we're going to define a few other things. Again, you might have already defined these, but we're going to review it. So the base of the isosceles triangle is this part right here. So the leg that is, or the two sides that are not congruent, there are two sides that are congruent in an isosceles triangle. The third side is known as the base. Phew, some of my difficulties there. Okay, these angles that connect the congruent side to a base, the congruent side to a base, these are called the base angles. So these base angles are right here, and this bottom left corner and the bottom right corner. So those are our base angles. The vertex angle is this, it's the other angle. So it's up here at the top of an isosceles triangle. So this is the vertex angle. Okay, so I'm color coordinating here. That's my vertex angle. And then the two sides that are not the base, so we have this blue side here, right, and this blue side here, those are called my legs. So the two sides that are congruent to each other are called the legs. So we have our base. We have the two legs that are congruent. We have these two base angles down here, and we have this vertex angle. So what you can see, or what you need to understand, another word is the word opposite. Okay, so what is an opposite angle inside? So a leg, let me move my compass here. A leg is opposite a base angle. Or a base angle is opposite a leg. So this base angle here is opposite this leg. This base angle here is opposite this leg. So angles are opposite legs. This leg is opposite this base angle, this leg is opposite this base angle. This base angle is opposite the leg, the base angle is opposite the leg. It goes both directions. So let's read this isosceles triangle base angle biconditional. So it's combining theorems 4.1 and 4.2 in the book, and it's another biconditional. It says two sides of a triangle are, well, we're talking about an isosceles triangle, so they are congruent. So two sides of a triangle are congruent if and only if, so these two sides are congruent if and only if the angles opposite those sides are congruent. So this angle opposite the side, the angle opposite the side, if these two angles are congruent, then the two sides are congruent. If the two sides are congruent, then the two angles are congruent. That's what the if and only if tells us. If two angles of a triangle are congruent, it's an isosceles triangle, and therefore the opposite sides, the definition is that their sides are congruent. If two sides of a triangle are congruent, then their base angles are congruent. The angles opposite of them are congruent. If two angles of a triangle are congruent, then their sides opposite, those legs, are also congruent. So it's an if and only if. So that's my theorems 4.1 and 4.2 are the isosceles triangle base angle biconditional. Okay, let's look at our corollaries here. Again, we're just practicing. Construct two different equilateral triangles. Two different equilateral triangles. Well, I'm going to start with the base over here. So what do you do to construct an equilateral triangle? Oops. So the first thing I need to do, I'll erase this little mark here, is I need to open my compass to be the width of that segment I just drew. And then I'm going to make my little arcs up here in the air, and I'm going to move my compass to the other end point of that segment, and I'm going to make my mark up here, and then I'm going to connect. So I'm going to connect this point of intersection out here, and I'm going to do the same on the other side. So here is one equilateral triangle. So all three sides are congruent. Okay, how do we make a different one? Well, let's make a different one. Again, what do? We start with the base. Okay, I'm going to put my compass edge on the base. I'm going to open my compass out to measure exactly the same width. I'm going to swing it up here, make an arc. I'm going to go to the other end point. Swing it around, make another arc. There's my point of intersection. So what do? I connect my point of intersection to the end points of the base that I started with. And so this is another equilateral triangle. Okay, well there's two different triangles. So what do we know about each angle of one of these triangles? Well, we know each angle is 60 degrees because that's a corollary we learned when the triangle sum theorem. That was a corollary. Well, if this is equilateral, each angle is 60 degrees. If this is equilateral, each of these angles is also 60 degrees. But are these two triangles congruent to each other? So are these two equilateral triangles congruent to each other? If they're congruent to each other, that means they're the exact same size and shape. Are these two triangles the exact same size and shape? No, they are not. So if they are not the same size and shape, then angle, angle, angle is not a congruence postulate. So if you can prove three angles of one triangle are congruent to three angles of another triangle, that does not mean the triangles are congruent to each other. We've just proven that right here. This is an equilateral triangle, all 60 degrees. This is an equilateral triangle. All these angles are 60 degrees. Are they the same size and shape? No. Therefore, this is not a congruence postulate. So be careful if you ever see AAA given. Okay, but let's fill out these corollaries. An equiangular triangle corollary. We'll call this corollary 1. An equilateral triangle is also equiangular. So we just saw that right there. Equilateral, all three sides are congruent, all three angles are congruent. So equilateral is also equiangular. Equiangular triangle angle corollary. We'll call this corollary 2. That's the way it will be on the theorem sheet. An equilateral triangle has three 60-degree angles, right? All these angles are 60 degrees. Equiangular triangle side corollary. An equiangular triangle is also equilateral. So you can see these two right here are converses of each other. Right? An equilateral triangle is equiangular. Well, an equiangular triangle is also equilateral. Okay, let's move on. It says construct an isosceles triangle, bisect the vertex angle, then construct an isosceles triangle, bisect the base. So you might want to try this on your own. If you do, go ahead and pause and do this on your own. If you don't want to do it on your own, you can follow me now. So first thing I'm going to start with is my base. I'm going to put my compass tip on the end point of the base, open it to some length, make my little arc up here. I'm going to move it to the other side of the base, the other end point, make my arc, make it intersect, and then I'm going to take my ruler and connect the intersection to the end points. Okay, so there's my isosceles triangle. These are congruent to each other. Now it says bisect the vertex angle. Okay, once again, where's the vertex angle? These two down here are base angles. This angle up here is the vertex angle. So we need to bisect it. So you have to practice bisecting your angle. So what do we do to bisect an angle? You put your compass tip on this end right here, on the vertex angle, and then you make your arc through the two sides. Then you move your compass to where the arc intersects a side, and you make another arc, and you move it to where the arc intersects a side, and you make another arc, and then you line this up. So I line up my vertex with that intersection down here, and I've just bisected the vertex angle. And if you notice, what does it look like is happening there? If you were to make a conclusion, a hypothesis, a conjecture, what would you determine? What do you think is happening? Okay, that's bisecting the vertex angle. What we know for sure right now is that these two these two angles are congruent to each other. So we call this angle 1 and angle 2. Angle 1 is congruent to angle 2. How do we know that? Because we just bisected the vertex angle. Okay, let's move on to the next one. It says, construct an isosceles triangle, bisect the base. You know what? I'm going to keep this same triangle over here, and I'm just going to bisect the base. Okay, I'm just going to do the bisection of the base, so I have the same triangle over there. You can do the same. Let's just bisect the base. So I'm going to use a different color. Okay, bisecting the base. So now I have to take my compass, and I'm just going to do the perpendicular bisector through here. So remember, I have to open it wider than halfway, and I have to do my scoop on the bottom and on the top. I move my compass over here, and I scoop the bottom and the top, and what do you notice? And I'm a little off because, and you might be too, but what do you think should happen? What do you think these intersection points should have been? They should have been exactly on this same angle bisector. So bisecting the base and bisecting the vertex angle result in the same line segment here. So when you bisect a vertex angle of an isosceles triangle, it turns into the perpendicular bisector of the base. Right? The perpendicular bisector. What does that mean? It means that this intersects the base at 90 degrees. And if it's a bisector, that means it splits the base into what? Into congruent parts. Or, right? Into congruent parts there. Congruent segments. So let's read this isosceles vertex bisector corollary. Isosceles vertex bisector corollary. It says the bisector of the vertex angle of an isosceles triangle is blank to the base at its blank. So it is, hopefully you're thinking to yourself, perpendicular. So it is perpendicular to the base at its what? What is this point called right here? Hopefully you're saying to yourself, at its midpoint. So it is perpendicular to the base at its midpoint. So it breaks it into two congruent parts. Okay, moving on. Here are some questions that apply what was learned. Let's find some missing values. Again, you might want to pause and try these on your own. Pause, try to find X on your own, then come back and check your answers. Okay, number 1. This is a 30-degree angle that's given. We're trying to find X. Well, we have a mark here and a mark here, which means this is an isosceles triangle, and these two sides are congruent. If I follow that to its opposite angle. That means these two angles are congruent to each other. So if this angle is x, this angle is also x. And what do we know about the three angles of a triangle? Well, hopefully you're saying to yourself, if I add them together, because of the triangle sum theorem, they total 180 degrees. So I have an x here. Well, this is the same. These two angles are congruent. So basically I have 2x. So 2x plus 30 equals 180. Subtract 30 from both sides. So 2x equals 150. Therefore, x equals 75 degrees. Right? Divide each side by 2, so x equals 75 degrees. All right, let's look at question number 2. Question number 2 says this angle right here is 56 degrees, this angle right here is 62 degrees. Well, 56 plus 62, that's 118 degrees. So therefore, immediately I can find the third angle. Well, I subtract 180 minus 118, what do I get? I get 62 degrees. Oh, well if this is 62 degrees and this is 62 degrees, I have an isosceles triangle. The sides opposite those angles must be congruent to each other. So according to the ITT, the isosceles triangle base angle biconditional, right? That's right here. The isosceles triangle base angle biconditional, ITBAB. ITBAB. Then two sides of a triangle are congruent if and only if the angles opposite those sides are congruent. So it's if and only if. So if these two angles are congruent, then their sides opposite them are congruent. So what is x then? X has a length of 42 units. Okay, number 3, let's find the perimeter. So this angle is congruent to this angle here, therefore side opposite x plus 5 is equal to side opposite 2x minus 4. 2x minus 4. So what do we do? Well, we have to solve for x. So I subtract x from this side. I get 5 equals x minus 4. I add 4 to both sides. I get x equals 5. So if x equals 5, how do I find the perimeter? Well, I have to plug 5 into each length. So 5 plus 5, that gives me 10 here. 2 times 5 plus 2, that gives me 12. And then this should be 10 because these sides are congruent to each other. Let's check. 2 times 5 minus 4. 5 plus 5 is 10. 2 times 5 is 10. 10 minus 4 is 6. I don't know what happened. I guess I did the math wrong. Those two equal each other. What did I do wrong? Oh, I put a 5 instead of a 9. Hee hee, sorry. 5 instead of a 9. Let's go back and fix that. My fault. You guys probably thought I was crazy. I was a little bit crazy. Okay, 9 plus 5 is 14. Then we have 18 minus 4, which is 14. There we go. See, that was good. This is the way you check to see if you did the problem correctly. I made a mistake. I knew that. I knew this had to be isosceles. I knew these two numbers had to be the same. They weren't, so I knew I made a mistake. So there, I found it. Awesome. Okay, 18 plus 2, that's 20. So my perimeter, 14 plus 14 plus 20, well, that's 28, 38, so it's 48 units. All right, so those are some example problems you would have in your textbook for homework. But not only that, we're going to continue with our good old proof. So here are 2 proofs that will involve isosceles triangles. So let's try to figure out what's given, how we go about proving this stuff. Okay, so step number 1. Remember, one of the things you might want to do is mark the information over here on the given diagram. So it says angle 1 is congruent to angle 2, so I'm going to mark that. I'm also going to immediately put that in number 1 up here, right? So angle 1 is congruent to angle 2. Why do we know that? Because that's given. Okay, what can we do next? Just from that information alone, if you have something given, there's a reason it's given, you should be able to make a conclusion from it. Based on that given information, what do you know immediately? Well, hopefully you're looking at these 2 angles, like 1 and 3. What are 1 and 3? Those are vertical angles. And if 1 and 3 are vertical angles, that means that those are congruent to each other. So angle 1 is congruent to angle 3. Well, 2 and 4 are also vertical angles. So I can also put here in the same line, angle 2 is congruent to 4. I'm putting them all on the same line because my reason or my justification, right? Remember, your reasons are justifications. My justification is the exact same. So what is the reason that angle 1 is congruent to angle 3 or angle 2 is congruent to angle 4? That's the vertical angle theorem. Okay, so now what do I know? I know that angle 3 is congruent, angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2. Well, really what we now know is all 4 of these are congruent because of this information here. But I don't really want to know that all 4 are congruent. I just want to know that these 2 are congruent because I'm trying to conclude that OK is congruent to OJ. That's where I'm trying to get. Well, what do you notice? Those sides are what? Those sides are opposite the angles right here. And sides opposite those angles, well, if these angles are congruent, then these sides the opposite sides must be congruent. But before we can conclude that those opposite sides are congruent, I must establish that angle 3 is congruent to angle 4. I haven't done that yet. So angle 3 is congruent to angle 4. Why? Well, we used to say that angle 1 was congruent to angle 2. What did we do? We put angle 3 in for angle 1, and we put angle 4 in for angle 2. And we rewrote that sentence, that mathematical sentence. So if you put something in for something else, that is called what? That's called the substitution property. So this is the substitution property. Then how can we conclude? So now that I established that these 2 angles are congruent to each other, then I know their sides opposite are congruent. And remember, I just called that ITBOB. It's the isosceles triangle base angle biconditional. The isosceles triangle base angle biconditional. ITBOB. Okay, I would say try to pause now and try the last one on your own. So give your brain some time to think about it. See if you can come up with what's happening on your own. Remember, your first line is going to be all of the given. Your last line that you write should be what you're proving down here. So first line, it's all the information that is given. Those are the statements. How do you know those are true? Because it was given right here. So here are the statements. How do we know it's true? Because it's given. So go ahead and pause and try to figure out the rest. Okay, so I'm going to mark the diagram first. So I know that AB is congruent to CB. It's hard to mark this diagram because AB and CB have been split here with this line J. So really it's hard for me to make a mark because if I make a mark here, it looks like I'm saying these 2 pieces are congruent. So it's hard to write that mark. So really I tend not to write the mark. I tend to just maybe color coordinate them. So AB is congruent to BC. I also know that J is parallel to K. Okay, that's helpful. It has to be helpful. They don't give you information if it's not helpful. So there's a reason that this was given. We have to figure out why. Why was that information given? Okay, well, let's go back to maybe something that's a little more obvious. Segment AB is congruent to segment BC. So AB is congruent to BC. If these 2 sides are congruent to each other, that means we have an isosceles triangle. My base is AC, one leg is AB, one leg is BC. And if sides of an isosceles triangle are congruent to each other, then what do we know about their opposite angles? We know that they are also congruent to each other. So I'm going to go ahead and put numbers in there because it makes it a lot easier to write. So if I put a 3 down here in this lower corner by A, put a 4 over here, then what can I conclude about angle 3 and angle 4? Well, if they're opposite congruent sides, those angles must be congruent to each other. Why? Because of ITBOB. ITBOB. Right, so ITBOB. Isosceles triangles, base angle biconditional. If sides are congruent, then their opposite angles are congruent. If angles are congruent, then their opposite sides are congruent. So now we know that angle 3 is congruent to angle 4. Okay, that was using this piece of given information. Now, how can we go back and use given information that J is parallel to K? If J is parallel to K, why is that going to help? Look, what are we trying to prove? We're trying to prove that 1 is congruent to 2. Well, hopefully you're saying, wow, that's easy. Hopefully. Here's a transversal going through 2 parallel lines. How do 1 and 3 relate to each other? So angle 1 is congruent to angle 3. Why? Because they are corresponding angles. Then hopefully you're saying, well, that's also true over here. Angle 4 is congruent to angle 2. We have to write it separately, though. Angle 4 is congruent to angle 2. Why? Because they are corresponding angles. Awesome. So now we have all 4 of these angles we know are congruent to each other. Right? So we have all 4 of these angles are congruent to each other. Angle 1 is congruent to angle 2, it's congruent to angle 3, it's congruent to angle 4. But I don't want to conclude that. I just want to conclude that angle 1 is congruent to angle 2. So do I need both steps? I don't think so. I think I only need one. I can now conclude that angle 1 is congruent to angle 2. How do I make that conclusion? What's my reason? What's my justification? Well, here's 3, and if 1 is congruent to 3 and 3 is congruent to 4, well, now I can substitute in 1 into 3, and I can substitute in 2 into 4. And so because of the substitution property, I now know that angle 1 is congruent to angle 2. So there are some examples of proofs with isosceles triangles. Hopefully you can see that visual, those sides, the angles opposite of them. You understand that the sides of an isosceles triangle are congruent, therefore the base angles of an isosceles triangle are congruent. If base angles of a triangle are congruent, then the sides of that triangle are congruent, and it's an isosceles triangle. Okay, get started on your homework. Please ask your teacher if you have questions or see us during a help session. Good luck.